The purpose of this video is to demonstrate the behavior of sample means when we take random samples from a population. The population we will work with is the top 200 movies of 2011. Our population is displayed in the left-hand column. At the top we see each movie represented by a gold sphere and labeled with the amount it grossed in millions. In the middle window we see those same 200 movies in a table, and in the bottom window we see a dot plot showing the amount each movie grossed in millions. The center column shows us our randomly chosen sample of 10 movies. When I click on the Sample More Cases button, we will see a randomly chosen sample of 10 movies. They are represented by blue spheres in the top window, shown in a table in the middle window, and displayed in a dot plot of gross earnings in the bottom window. If I click the Sample More Cases button again, we will see a different sample of 10 movies, just as you and your classmates saw. The right-hand column shows the sample means of the sample of 10 movies. When I click the Collect More Measures button, notice that a new sample of 10 movies is selected, and the mean of that sample is displayed as a green sphere labeled with the sample mean. We can also see a table of the sample means and a dot plot of the sample means. If I click the Collect More Measures button again, we will see a different sample of 10 movies with a new sample mean. There are now two different sample means from two different randomly selected samples of 10 movies. I will now turn off the animation to speed up the process of collecting many sample means. In fact, let's generate 500 more sample means. Watch the dot plot at the bottom of the right-hand column. There are two important facts to notice about this process. The first fact is that random chance actually behaves in a predictable way in the long term. There is a pattern emerging from all those sample means. This lets statisticians make inferences or conclusions about the population with some degree of confidence. The second fact to notice is that the center or mean of the sample means is very close to the population mean. In fact, if I collected all possible samples of 10 movies, calculated the sample mean from each one of them, and created a dot plot of all those sample means, their center, or mean, would be exactly equal to the population mean of $50.2 million. When the center, or mean, of a statistic equals the population parameter, we call that statistic an unbiased estimator of the population parameter.